Hello everyone, good afternoon. This is Mahmood-Ul and I'm going to present penciling of flexible and eco-friendly touchpad on paper for disposable user interface. This is the outline of my presentation. These points will be covered one by one in the upcoming slide. This is the basic introduction of Nanotech Lab at Information Technology University, Lahore, Punjab, Pakistan. Basically, in this lab, we are working on different domains like plasmonics and metamaterials, semiconductor devices, and micro nano sensor for healthcare. Uh, we are being supervised by Dr. Kashif Riaz and Dr. Qasim Mehmood and Dr. Zubair, and the other faculty member who are assisting in our work are Dr. Tawsif Tokir and Dr. Usman Yunus. This is our team, our research group, which is working at Nanotech Lab. Uh, if we talk about the touch sensing system, basically there are different types of touch sensing system. So we have explored three of them: infrared, resistive, and capacitive. So infrared touch systems are highly sensitive, but these systems consume high power and fabrication cost is also high. As for the resistive touch systems are concerned, these are easy to fabricate, but the problem which relates to this system is less repeatability. The capacitive touch systems are high repeatable, low cost, less power consumption, and also robust. Uh, so our focus in this work is basically on the capacitive touch systems. Further classifications, we can see that interdigitated and parallel plate. Interdigitated systems are high repeatable than parallel plates. So our focus will be on interdigitated touch systems. Uh, the capacitive touch systems are being used in different applications like e-skin, smart packaging, automotive, wearable, and soft human machine interface. So we can see that these capacitive touch systems are immensely used in different applications nowadays. So the problem which we are going to address in this work is that the already available solutions are that they have some problems, like they are indestructible and rigid. Fabrication processes are energy extensive. Environment unfriendly materials and fabrication techniques are being used to fabricate these sensors. Uh, these sensors are also producing the e-waste because they are not easy to dispose of. Special and high cost material are being used to fabricate these sensors. So we are trying to address these problems in our work. So the image shows the working principle of IDC sensor, which we have developed in our work. In the A part, we can see the fabricated sensor, which is basically graphite pencil has been used to fabricate the sensor on a simple cellulose paper. In the B section, the working principle is shown for the sensor. The working principle basically shows that the in-plane capacitance, capacitor has three different types of capacitances in plate, in between the plates, or the we can see the electrodes is the C2. uh, epsilon naught epsilon 2 is basically the dielectric constant in between these electrode. The other two capacitances are C1 and C3. C1 is above the electrodes and C3 is beneath the electrodes, and epsilon 1 and epsilon 3 are basically the corresponding dielectric constant for C1 and C3. So the electric constant will remain same in case of paper substrate, and C3 will not change on the if we touch the sensor. Here we can see that if we place a finger above the sensor, then E1 the dielectric constant will change, which ultimately affect the C1 capacitance. And C section, we can see the electric field lines. which are passing through the plates and the substrate. In this section, we can see that on if we touch the sensor above, the C1 will change because before the dielectric is related to air, but now if the finger is placed on the sensor, then the dielectric constant will change accordingly. This is the fabrication process of our sensor. Here we can see that the step one is basically a paper substrate. The paper is basically commonly used cellulose paper, which is being used for printing process. Sensor in the step two, we can see the sensor design. Sensor design basically is here we can see the W is the width of the fringes, G correspond to the gap between the fringes, L is the common length of the fringe. Uh, Uniform for the uniform, the sensor is printed on the paper substrate, which can be seen in step three. Step four basically shows penciling of the printer design. To attain the uniform properties, repetitive penciling is done for this purpose for this purpose. This is the experimental setup to check the working of our proposed design. Here, Arduino is used as a microcontroller. AC5 is basically Bluetooth module, which is used to communicate with the Android app. LEDs can be seen here, which will respond to the capacitive touch, and LCD is also on the right side. We can see that it will show the corresponding results as well. This is the basic layout of a touchpad. Here we can see that we have named the sensors corresponding to the LEDs, green, red, yellow, white, blue, and the layout shown on the right side is basically Android app, which will respond on the touch. This is the single sensor response. Here we can see that without touch, the capacitance value is lower, and when the finger is placed on the sensor, the capacitance change, and we get a different value for that touch. This is the basically 20-second sample. Here we can see on the repetitive touch, the capacitance is being changed. For microcontroller, we have like decided to work on a six picofarad as a threshold value. This is another response, which is basically correspond to the five sensors which I have already showed here. The name which are given to these sensors correspond to the LEDs. Here we can see that sensors are responding to the touch. Another factor which we can see that we have touched different sensors simultaneously, and the results can be shown. Like if you see that after 10 seconds, yellow and white is being touched simultaneously, and the sensor is responding according to those touches. This is the demonstration of the results. When we touch the red sensor, here we can see that the result is being shown on the Android app. The same result is being shown on the LCD, and the red LED is also on for this after touching the red sensor. This is another demonstration. Here we can see the white LED is being on, and the results are being shown on the LCD, and the corresponding LED is also glowing. So after showing the demonstration, I will conclude my presentation. And our sensors are non-indestructible and non-rigid, low-cost procedure. I can see that it involves a simple printing procedure and eco-friendly process. It doesn't have any sort of greenhouse gas emissions and like the other adverse factors which impact the environment. Easy go design and easy to fabricate. The materials which are being used are easily available, like graphite pencils and cellulose paper, which is commonly used for printing processes, like It can be easily found anywhere. So this is from all my side. I would like to thank Flaps management team for providing us an opportunity to present our work. So if you have any questions, please do ask. My colleague Hamza Zulfiqar will be answering to your queries. Thanks all for listening.